Hello. So let's do another example. And just like in the previous examples, what we're looking for is we're looking for a composite function, and then we're looking for the derivative of the inside function multiplied somewhere else. And so just looking at this, x plus 3 times x minus 1 to the fifth, hopefully you can see that like this is a composite function. It's x minus 1 inside of, u to the fifth. And so maybe we can write down like u is equal to x minus 1. And then in that case, du is going to be equal to dx. The derivative of x is just 1, so du is equal to dx. And then now, however, we can see in our problem that we have more than just dx, right? We have this x plus 3 times dx. And unlike the previous problems where we could multiply by like a constant, we can still multiply a constant here. However, you cannot multiply by x plus 3, so that's not allowed. So if our problem were something instead like, x minus 1 to the fifth times dx times some like constant, times like 3 or something like that, then we could really easily do U-substitution. But that's not what we have. We have this kind of extra x plus 3 floating around, so we have to talk about what we're going to do with that. And to make it really clear, what I'm saying is that this is u, this x minus 1 is u, this dx, we said was du, and so if we wanted to rewrite this integral, this is the integral of x plus 3 times u to the fifth times du. So we have this kind of extra x plus 3 floating around, and it doesn't make sense to write an integral with both u's and x's. And so we need to figure out what to do with this x plus 3. And so what we can do is we can look at our relationship between u and x. So we have that u is equal to x minus 1. And so if we solve this for x, what we're going to get is that x is equal to u plus 1. And so then we can, for this x, put in u plus 1. So for this x right here, I'm going to put in u plus 1. And when I do that, this integral is going to change. This is going to be the integral of u plus 1 plus 3. So that's going to be u plus 4. And so what I did was, x is u plus 1. So u plus 1 plus 3 is going to be u plus 4 times u to the fifth times du. And so let's get rid of this because we can't have x's and u's in the same integral. And so then this integral is really this integral right here. And so now we can proceed. And so we can distribute the u to the fifth. And so then this is going to be the integral of u to the sixth plus 4u to the fifth times du. And then now, hopefully it's really clear why U-substitution was useful in this example. Because what we did was we took an integral that was, we weren't really sure what to do. We had this x minus 1 to the fifth floating around. We had this x plus 3. And now what we did was we converted it into just, a polynomial in u. And so we can just do the power rule. So we can do the power rule on these two individually. So this is going to be u to the 7 divided by 7 plus 4u to the 6 divided by 6 plus c. And then as a final step, we just plug back in our u. So this is going to be x minus 1 to the 7 over 7 plus 4 times x minus 1 to the 6 over 6 plus c. Great.